This is an introduction to APL. Monadic functions. A monadic function is a function that takes only one argument, to the right. A scalar monadic function is a function that takes only one argument, but which applies to each of the elements in it. For example, negation. Negation changes the sign of a number. If it was positive, it becomes negative, and vice versa. But it does it on each number in its argument, whether this was a vector, a matrix, or a simple number. There are other monadic scalar functions. A factorial is one of them. The absolute value is another one. Reciprocal, exponential, natural log, ceiling, floor, and logical negation. They are all monadic scalar functions. And now if we look at negation, we can see that if we negate a series of numbers, all those that were positive become negative. All those were negative with a high minus sign become positive. It just changes the sign of a number. Factorial returns the product of all the numbers from 1 to n. So if you say factorial of 4, this is the same thing as saying 4 times 3 times 2 times 1. Of course, if you supply it a series of numbers, it will apply to each one of them, seen in the bottom example there. The absolute value returns the number without its sign. If it was negative, it becomes positive. If it was already positive, it does not change. The reciprocal is the same thing as doing 1 divided by the number. So the inverse of 5 is 0.2. The inverse of 0.2 is 5. Exponential returns the value of e exponent n. E is the base of what is called natural logarithms. Natural logarithms returns the value of log n using e as the base in what is called natural logarithms. It is the inverse of star. Monadic star. Logical negation. Negation of any Boolean value returns a negation of those logical values. If it is true, it becomes false. If it was false, it becomes true. If it's 0, it becomes 1. If it's 1, it becomes 0. Ceiling. This applies to fractional numbers. If a number is fractional, taking the ceiling moves it up to the next integer. The floor is the opposite. It moves it down to the next integer. Roll allows you to pick numbers at random from 1 to n. For example here, if I want to pick any 3 numbers from 1 to 10, I ask roll 10, 10, 10, and that will pick 3 numbers at random from 1 to 10 in each case. The signum returns the sign of a number. Minus 1 if it was negative, 0 if it was 0, and 1 if it was positive. Pi. Pi 1 returns the value of pi. Pi 2 returns twice that number, and so on and so on. Now, dyadic circular functions. These are all trig functions. You can get them all in APL. You use the same symbol as pi, except that you give it a left argument. Again, this is a scalar function, meaning that each of the numbers in the left argument applies to each of the numbers in the right arguments. In other words, you can have sine and cosine of 2 numbers on the. So if the number on the left is 1, we're asking for the sine. If it's 2, it's the cosine. If it's 3, it's the tangent, and so on and so on. There are many other primitive functions, and those functions do not apply on a number by number basis. They're not scalar functions. They usually apply to the argument as a whole. For example, we've seen reshape, which reshapes the entire argument to the right. So it doesn't apply 1 to 1. The left argument applies to the entire right argument. Those are often called structural functions. An example of a structural monadic primitive function is shape, rho. Same symbol as we've seen as reshape. This time it's the monadic form. It returns the shape of its argument. If it's a list, it returns the number of elements. If it's a table, it returns the number of rows and columns. For example, row of 4 numbers returns 4. With the table, if I ask for the row of a table or the shape of a table, it returns 2 numbers, number of rows and the number of columns. So, to recap, there are many other monadic functions. There are dyadic circular functions. They all use a number to the left to specify which function to use. And there are other non-scalar functions that apply to their arguments as a whole. For example, shape. That's it.